Another classification matrix is called F1 score, which is combining precision and recall. F1 score is a harmonic average or mean between precision and recall. The range of values for F1 score is between 0 to 1. The greater the value for the F1 score, the better the performance of the model. The formula for F1 score is as follows. So it's a combination of precision and recall. So it's equal to 2 times the precision multiplied by recall divided by the summation of precision and recall. Or if you want to use the table, the number of true positive and negatives, it's equal to 2 multiplied by the number of true positives divided by 2 multiplied by the number of true positives plus false negatives. There is a more general formula for F score, which we showed by F beta score, and that's equal to 1 plus beta square multiplied by precision multiplied by recall divided by beta square multiplied by precision plus recall. Or in terms of true positive and false negative, it's going to be 1 plus beta square multiplied by true positive divided by 1 plus beta square multiplied by true positive plus beta multiplied by false negative plus false positive. Beta here in this formula allows for adjustment of the metric to control the emphasis on recall versus precision. For example, for precision-oriented applications, we're going to set beta to 0.5. And for recall-oriented application, we're going to set beta equal to 0.5. But F1 score, as you see, is a specific formula which is going to put beta equal to 1. That's why we call it F1 score. And we will work more with F1 score in this course. Next on classification metrics is classification report, which actually is not a metric. Classification report is just a convenience way or report provided by Scikit-Learn that would give you a quick idea of the accuracy of your model using a set of measures, including precision, recall, F1 score, and support for each class in your data. So what you can do is you can actually compute and print out all of these measures alone, as you can see here, by this line of code. From Scikit-Learn metrics, import accuracy score, precision score, recall score, F1 score, and then compute each metric such as recall score by providing the Y test and Y predict, and also for other measures as well. Also, you could ask Scikit-Learn to print out the classification report that would actually include all of them. So as you can see here, this is a printout of the classification report for the MySVC model that we already had before. As you can see, it has printed out and computed the precision, recall, F1 score, and support for both classes, 0 and 1, and also the average. What is support? Support shows the total number of data points in the dataset that has the true labels. So for example, here we have 407 data points that have the true 0 label. Another classification matrix is called a specificity or false positive rate FPR. A specificity corresponds to the proportion of all negative data points that are incorrectly classified as positive. So as you see in the table here, a specificity formula is defined as false positive divided by true negative plus false positive. So that's how much of your true negative has been classified incorrectly as false positive. A specificity, you can see it as the recall of the negative class. Another classification matrix is the ROC curve, or specifically is the area under the ROC curve. The ROC curve, which stands for the receiver operative characteristic curve, it's not that useful by itself, but the area under the ROC curve is useful. The area under the ROC curve is a performance metric for binary classification problems. It represents a model's capability to distinguish or discriminate between the two classes, positive and negative classes in binary classification. To give you an idea of the range of the AUC values, a perfect model would give an AUC score of 1. On the other hand, a model with a AUC score of 0.5 or 50% is as good as random classification or tossing a coin, for example. A binary classification problem is really a trade-off between sensitivity, or as we call it, recall, which is the percentage of instances from the first positive class predicted correctly, and a specificity, which is the percentage of instances from the second negative class predicted incorrectly. As mentioned earlier, the AUC is the area under the ROC curve, which is basically the plot of false positive rate versus the true positive rate for a classification algorithm plotted at different points in the interval of 0 to 1. So this is an example of the ROC curve that you can see. On the x-axis, you can see the false positive rate, and on the y-axis, you can see the true positive rate from 0 to 1 for both. So this is the ROC curve that you can see here. The baseline, which is shown by the dash red line here, is a random classification output, or is the average, which is 50% accuracy rate, such as flipping a coin. So that's going to give us an idea of how good our the performance of our algorithm is based on the ROC curve. So a random classification algorithm would give a AUC of 0.5. The ideal point here in this ROC curve is the top left here, the top left corner. That's the ideal point, which is the false positive rate is 0 and the true positive rate is 1. In the ROC curve, the steepness is important to us because we want to maximize the true positive rate while minimizing the false positive rate. Let's see now how the ROC curve and AUC works in Python, or specifically in Scikit-Learn. We can actually plot the ROC curve for a predictive model in Python or Scikit-Learn using the following lines. So to do that, we can use the ROC underscore curve, a function that we can import it from the Scikit-Learn metrics library. Here, FPR stands for the false positive rate and TPR stands for the true positive rate. So the ROC curve function from a scalar takes the true outcome, the y-test, and the predicted probabilities of y-predict, and would return the FPR, the false positive rate, and the true positive rate, and also the thresholds. Note that to get the predicted probabilities for the support vector machines, we need to set the probability parameter to true when defining the SVC model. Here is an example of the ROC curve in Python Scikit-Learn, which we plotted for the SVC with RBF kernel and linear kernel. The next classification matrix that we want to talk about is the logarithmic loss, or the log loss for short, which is a performance metric specific to logistic regression, which is used for evaluating the predictions of probabilities of membership to a given class. The scalar probability between 0 and 1 can be seen as a measure of confidence for your prediction. Predictions that are correct or are incorrect are rewarded or punished, respectively, proportionally to the confidence level of your prediction.